Well, hello everybody. Here's what we're going to be covering today. I'll cover day 2 of our sequence and series unit. If you were there, I would have answered any questions over worksheet number 1 for you. Hopefully you did miss a homework quiz, so you need to get that in and get made up. And then you should have the class notes right in front of you. Those will be what I'm going to go over today with you. Not a hard unit. I will give you a note card and let you write down a formula in the very near future. So for today, when we come across the arithmetic sequence formula, write that down on a piece of paper, and we will transfer that to our note card in the very near future. But some of this is going to tie into what we did last time. So look at your paper there. Look at the first 3 sequences that I've given you. The first pattern goes 1, 4, 7, and 10. I'm sure you can look at that and predict the next 3 terms. There's going to be a 13, there's going to be a 16, and there's going to be a 19. Why? Because we're adding 3, and then we're adding 3, and then we're adding 3, and then we're adding 3. So every time. If you look at your next one, looks like we added 1, then added 2, and then added 3, added 4. Well, we're probably going to predict that we're going to add 5, and then 6, and then 7, and then we got it. So just patterns for a second. On your next one, well, probably from there to there, I'm adding 5, and then 10, and then 15. You'll probably predict that we're adding 20 to get 53, and then 25 to get 78, and then we're going to add 30 to get 118. Those are all examples of just patterns today. But what I'd like to concentrate on today is a certain type of pattern called an arithmetic sequence. A pattern becomes an arithmetic sequence if the exact same number is added or subtracted every time. Only one of these is an arithmetic sequence. Some people try to pronounce this arithmetic. Really, it's arithmetic. Well, hopefully you thought, and number 1 is my only arithmetic sequence because of this plus 3, plus 3, plus 3, plus 3. The others have a pattern that we can figure out, but it's not using the same number every time. This is not on your notes. It ties into what we talked about last time, some notation. Just like last time, a sub 1, we're going to use a today because we know these are arithmetic sequences. A sub 1 is still the value of your first term. A sub 2 is still the value of your second term. A sub 3 is the value of your third term. And a sub 4 is the value of your fourth term. Just like we had last time. Just notation. I will introduce D to you today. D stands for difference. And what we mean by that is what are we adding or subtracting every time to go from term to term. In this case, my D value is positive 4 because we're adding 4 every time. This is not on your note sheet either, but let me show you my little pattern here. Given that a sub 1 is 22 and D equal 3, list the first 5 terms. Well, you're told what the first term is. It's 22. D is 3, so you're going to add 3 every time. So 25, 28, 31, and 34. That's all there is to it so far. Here's my second one that is not on your note sheet. Given that a sub 1 is 100 and D is 10, list the first 5 terms. Well, it's going to look like this. A sub 1 is 100. And then add 10, add 10, add 10, and add 10. And then you got it. Here's my last one. Given a sub 1 is 200 and D equal negative 8, list the first 5 terms. Hey, it's okay for D to be 8 That just means my sequence is going down. Big deal. So there's a 200. Subtract 8 and get 192. Subtract 8 again and get 184. Subtract 8 again and get 176. And one last time, 168. So like I said, those were not on your note sheet, but that's how we generate some terms. Okay, if you will, now look at your chart. Here's what I want to do on this one. I want to show you how we derive a formula. So I'm going to give you some sequence. Notice this thing is arithmetic. I know it's arithmetic every time because I'm adding 4 every time. So hang with me for a second, see if you can figure out what I'm going to do. Here's the term I want to talk about. 1, 2, 3, 4, 10, 20. 20 is not on your worksheet, by the way. 100, and then any term that I want to talk about. Well, here goes. The value of my first term, if you look up here, it is 2. The reason? It was given. We had to start somewhere. So there's where we started. Now I'm going to write this a certain way. My second term has a value of 6. Why is that? We took that 2 and we added 4 to it. My third term has a value of 10. Why is that? We took that 6 from above, which I'm going to write down as 2 plus 4, and we added another 4 to it. How about my fourth term? My fourth term is 14. Why is that? I took that 10 from above, which I'm going to write down as 2 plus 4 plus 4, and then add another 4 to it. Well, now I want to think about the 10th term, and then the 20th term, and then the 100th term. So I can think of any term that I want. So think about the 10th term for a second. Any idea what it may be? Well, think about this, guys. My second term had a 1, 2 in there and 1, 4. My third term had the starting number 2, and it had 2 4s. My fourth term had 3 4s. Well, does it make sense that my 10th term would have the 2 that we started with, and then 4 9 times? There's a total of 10 terms here. 9 of them are 4s, 1 of them is a starting number. And if you run that through your calculator, you're going to get something like 38. My 20th term is going to have a 2 in there, so I've taken care of 1 term. And it's going to have a 4 19 times. So 4 times 19 would be 38, 76, plus 2 is 78. The 100th term, hopefully you're seeing my pattern here, would have the 2 in front of there, and it would have a 4 99 times. So the 100th term, meaning if I gave you this sequence and made you write it out 100 times, you would write down the number 398. But I want to put this into a formula that will work for anything that I want it to work for. So think about this. Where did we get this 2 from? We had to start somewhere. So I'm going to start generating a formula. A sub n, which means any term that I want to talk about, is going to be given by a sub 1, the very first term, plus my d value, which in this case happens to be a 4. But it's going to be my d value, and then notice this. The second term had 1 4, the third had 2 4s, the 10th had 9, so we're going to subtract away 1. I have this on the next slide, which I'll pause on for a second, but you need to write that formula down. Put it at the top of your class notes, but put it somewhere. I have a space for it right there below the box, where it says formula to obtain any term in the sequence. Write this down. So there it is. I'm going to give you a note card in the near future, and I need you to put on there that this is the formula for arithmetic sequence. You will have 4 formulas that you'll have on your note card. And then write this formula down. So I'm going to have you put this formula on your note card. Today it may be on your class notes, and label it accordingly. We will always simplify this formula, and I'll show you what I mean. This is an easy formula to use. You will only be placing 2 numbers in there every time. This will not change. This part right here will not change. So every time, guys, you'll be finding me the value of the first term and the difference. So while I got you a little bit confused, look at your very first problem. It says given 3, 9, 15, 21. Here's what I need to do. First, I need to decide, is this sequence arithmetic? Does it go up or down by the same number every time? And when you look at it, in this case, the answer is yes, because I am adding 6 every time. So now, look at your formula sheet. You're going to write down, I'm going to scribble that out so I don't mess you up. You're going to write down a sub n equal a sub 1 plus d n minus 1. There's the formula. Now here goes. A sub n does not change, so a sub n equal. You're going to go find me a sub 1. Well, here is a sub 1. It happens to be 3. Plus. My d value is 6. I'm going up by 6 every time. So I got 6 n minus 1. Notice the n minus 1 stays. Now I need you to simplify this thing. So when I simplify, I'm going to distribute. So I've got 3 plus 6n minus 6. I just distributed. As Algebra 2 students, we ought to be experts at that. And then combine your like terms. Combine 3 and negative 6. So here's my formula. A sub n equal 6n minus 3. There's my formula. Let me point out a couple of things. You have to have a sub n in there. If you just have 6n minus 3, it's not a formula. It's an expression. Now, get in the habit of checking all of these. All of our arithmetic sequences can be checked. So I call it the 1, 2, 3 check. And really, we can get by with doing the 1, 2 check. Here's what I mean. Let's find a sub 1 by plugging in 1. 6 times 1 is 6. Minus 3, I'm going to get 3. Notice that's my first term right there. Now let me plug in a 2. If I plug a 2 right here, 6 times 2 is 12. 12 minus 3 is 9. I know this is the right formula. So now I'm going to move on. The rest is easy. It says find a sub 40. What you're doing here is finding the value of the 40th term. So to do that, I'm going to say a sub 40 equal 6 times 40 minus 3. I'll run that through my calculator, and I'm going to get 237. Now let's find a sub 100. To do that, just plug 100 into your formula. So it's going to look like this. 6 parenthesis 100 minus 3. You can run that through your calculator, you're going to get 597. So the hard part was just right here, finding your formula. And to be truthful, that's not very hard. Now look at my next part. It says which term will have a value of 447. Here's what that means. If I made you keep writing this sequence out, keep adding 6, adding 6, adding 6, how many numbers will you write down before you write down 447? That's what we're looking for. So to do that, when it says which term has a value of, I'm going to go 447 equal my formula, 6n minus 3. And then we're just going to solve that, guys. I'm going to add 3 to this side and get 450 equals 6n. Then I'm going to divide both sides by 6 as I run out of room. And I'm going to get n to be 75. So that means the 75th term has a value of 447. That's what that means. So if you're looking for a value, plug in that number. If you're looking for which term has a value, set it equal to it. Hey, if I got you a little lost on that one, hang with me. Here's your next one. Another easy one. First, you need to decide if it's arithmetic or not. Looks like I'm going to add 11, add 11. So yes, this is arithmetic. So then you're going to write down your formula, which says a sub n equal a sub 1 plus d n minus 1. Now you're going to plug in a sub 1, which is 4. So I'm going to do that right over here for you. So I've got a sub n equal 4 plus, what's your d value? Hopefully you thought 11. So I've got 11 n minus 1. So once again, you found the first number and the difference. That's all you're plugging in. Now you're going to simplify. So I'm going to distribute. I'm going to get 4 plus 11n minus 11. When I combine like terms, I'm going to get 11n minus 7. So for my formula, guys, it's going to be a sub n equal 11n minus 7. Make sure it's right. Plug in 1 real fast. 11 times 1 minus 7, and it better equal 4. And then 11 times 2 minus 7, and it better equal 15. If it doesn't, you messed up somewhere. If you did, go find your error. Now to find the value of the 50th term, it's going to look like this. I'm going to go 11 times 50 minus 7. And I'm going to get a value of 543. To find a sub 83, I'm going to go 11 times 83 minus 7. So I just plugged 83 right there. And I'm going to get 906. For my part that says which term will have a value of 1313, I'm going to go 1313 equal 11n minus 7. And then we're going to solve that. So add 7 to both sides. So I got 1320 equal 11n. I'm going to divide both sides by 11. And the 120th term has a value of 1313. Let me point out something while I'm here. When you're doing this part where it says which term, it can never be negative. And it can never be a decimal. It's always got to be an integer of some sort. I've got 2 more to do with you, and then I'll ask you to pause the video and try 2 of them before I move on. So here goes my number, well, my next one, 50, 42, 34. Hey, notice, is it arithmetic? And the answer is yes, because I'm going down by 8. So in this case, my d value is negative 8. Be careful when your d value is negative. So it looks like this now. A sub n equal a sub 1 plus d n minus 1. Plug in a sub 1, which is 50. Plug in your d value. Even though your formula says plus d, it's negative, so I'm going to go negative 8 n minus 1. Now distribute, so I'm going to have 50 minus 8n plus 8. 50 minus 8n plus 8. Notice a negative times a negative is a positive. I will show you what happened if you didn't catch that. So I've got negative 8n plus 58. So my formula, a sub n equal negative 8n plus 58. Hey, make sure it's right. In your calculator, I'm going to go negative 8 times 1 plus 58, and I better get 50. I better get 50. And then I'm going to go negative 8 times 2 plus 58, and I'm going to get 42. So I know my formula is right. Hey, let me show you something real fast. Let's say that you got in a hurry, and you didn't remember that a negative times a negative is a positive. Here's your formula, negative 8n plus 42. Watch what happens when I plug in 1. Negative 8 times 1 plus 42 is 34. Man, 34 is not my first term, so I know that's got to be bad. Now to find the value of the 20th term, and technically that should be an A, I'm going to have negative 8 times 20 plus 58. So I get negative 120. Hey, a while ago I said you can't have a negative. I can if it's the number, but I can't the term number. Notice that these are going down. If I keep doing that, guys, I got to hit some negative numbers, so that's okay. To find the value of the 70th term, negative 8 times 70 plus 58 is going to be negative 502. So once you got this part, the rest just rolls. Which term has a value of negative 902? I'm going to go negative 902 equal negative 8n plus 58. Subtract away 58 from both sides and get negative 960 equal negative 8n. And once again, for about the third time today, I'm going to get the 120th term. Okay. I got another one just like that coming at you. And then you can pause the video and try 2 of them real fast if you'd like, or you could just let the video roll and watch me do them. So here goes my next one, 24, 18, 12. Well, I'm going to go a sub n equal 24. My d value is negative 6. So I've got minus 6 n minus 1. I've got 24 minus 6n plus 6. So I've got negative 6n plus 30. So my formula, a sub n equal negative 6n plus 30. It is wrong if you do not have a sub n equal in front of it, because then it's not an equation. To find the 25th term, negative 6 times 25 plus 30, and that's going to be negative 120, I believe. A sub 100, negative 6 times 100 plus 30, that's going to be negative 570. And then which term has a value of? I'm going to go negative 690 equal negative 6n plus 30. And just solve that. Subtract 30 and get negative 720. And like I said, it doesn't do this every time, but I'm going to get 120 again. Hey, now coming up on the slides now, guys, I have a couple that you could try. So if you would like, pause the video, and then try this one, maybe the next one, and make sure that you're on the right track. If you don't want to pause it, you can just hang on for a second. In about 5 seconds, I'm going to start picking this back up. So I'm going to give you time to pause it if you'd like. Okay, if you paused it or not, here's what it should look like. You should have went a sub n equal 8 plus 5 n minus 1. And then you should have went 8 plus 5n minus 5. And then you should have had 5n plus 3. So my formula, a sub n equal 5n plus 3. I'm going to plug in a 1 and make sure I get an 8. I'm going to plug in a 2 and make sure you get 13. If you go 5 times 25 plus 3, I believe you're going to get 128. And if you plug in 100, you're going to get 503. On this one, you should have went 753 equal 5n plus 3. Should have subtracted 3. Then you should have divided by 5. And I believe that's going to be 150 this time. So finally, something a little bit different. If you want to pause, hit pause real quick. Otherwise, on this one, we should have looked at a sub n equal 27 minus 3, n minus 1. I've got 27 minus 3n plus 3. I should have negative 3n plus 30 for my formula. And then I can plug in 20 and 75. If you did that, you're going to get negative 30. Looks like negative 225, probably negative 195, I'm going to guess. And then on this one, negative 270 equal negative 3n plus 30. Negative 300 equal negative 3n. N's going to be the 100th term. I got about 5 more minutes of video for you. I got to show you how to insert arithmetic sequences, but it won't be bad. So if you will, look at your next line there. Here's what we mean by inserting arithmetic sequence, arithmetic means. There's some number out there. I'm going to add it to the 2 and get another number. I'm going to add it to the next one and get a new number. Do it one last time, and I want to end up at 23. Let me show you what a wrong answer might look like. You think it's 5. 2 plus 5 is 7. Plus 5 again is 12. When I add 5 again, I don't get 23. So I know 5 is the wrong number. This one's not a bad one to do by trial and error. But let me show you how to do it. Remember that formula from earlier, that arithmetic sequence? That's what I'm going to use. So I've got a sub n equal a sub 1 plus d n minus 1. I'm trying to find the d value in this case. Trying to find the d value. A sub n is your last number. A sub 1 is your first number. So I'm going to go 23 equal a sub 1, which is 2, plus d times n is the number of numbers you're working with. 1, 2, 3, 4. 4 minus 1 is 3. To solve this, subtract 2. So I got 21 equal d times 3, which is the same thing as 3 times d. Divide both sides by 3 and get d to be 7. So I'm going to add 7 every time. 2 plus 7 is 9. 9 plus 7 is 16. 16 plus 7 is 23. Boom, you got it. Let's look at your next one. 5, blank, 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 71. Looks a little harder. So once again, I'm going to jot down my formula that I'm hoping that you have memorized by now. Remember, we're looking for the d value. So a sub n is 71. A sub 1 is 5. I don't know what d is, but n is 1, 2, 3, 4, 5, 6, 7. 7 minus 1 is 6. To solve this, minus 5 and get 66 equal d times 6, which is 6d. I just rewrote that so it looks better for you. Divide both sides by 6, so d is going to be 11. So we're going to add 11 every time. 5 plus 11 is 16. Add 11 is 27. Add 11 is 38. Add 11 and get 49. Add 11 and get 60. One more time and get 71. My next to last one, and then I got to toss a word problem at you. Once again, a sub n equal a sub 1 plus d n minus 1. If you'd like to pause the video and see if you can solve this one for yourself, you sure can. But I'm going to put 128 equal, oops, no I'm not. I'm going to put 68. To be truthful, it won't matter, but to stay consistent, I'm going to go 68 equal 128 plus d, and I got 1, 2, 3, 4, 5, 6, 7 numbers. 7 minus 1 is 6. Now when I solve this, minus 128 to both sides. So I got negative 60 equal 6d. Divide both sides by 6 and get d to be negative 10. So I'm going to subtract 10 every time. 118, 108, 98, 88, 78. When I do it one more time, I hit 68, so I know I'm good. So that's all there is to it so far. Like I said, I got one word problem coming at you. Hey, remember what we said about word problems all year? A word problem is a word problem for about 30 seconds. Just dig out the key information, and it's not a word problem. So here goes. As the Dillon's Employee of the Year, you are in charge of putting a display of the hottest energy drink to ever hit the market, called not Red Bull, but Matt Bull. I made that up myself. You plan on having one can at the top of the display. How many cans at the top? 1. So I'm going to write down a 1, comma. Then 5 cans. How many cans on the second row? 5. Then 9, and so forth. You plan on having the display 25 rows tall. How many cans will be on the bottom row? So I would like to find the value of the 25th term. Hey, now guys, this is no longer a word problem. It's just like what we've been doing. I need to find a formula, and then I need to plug in 25. So here goes. I'm going to go a sub n equal a sub 1 plus d n minus 1. A sub 1 is 1 plus 4 n minus 1. Distribute like we've been doing. 4n minus 4. Combine your like terms and get 4n minus 3. Plug in 25, and it tells me that you need 97 cans on the bottom row. So that's what we got going. The homework sheet's not very hard, to be truthful. If you really understand what you're doing here, it's about a 20-minute assignment is all. So good luck on that. If you have any questions, buzz in. Make sure you get that formula written down on your note card. Good luck.